In this video, we're reviewing the visual components sample from the code sample library provided with the ABBYY FineReader engine distribution pack. The steps we'll perform are described in detail here on the code samples library page. You can load the sample code and review it, or use it as a template for developing your own application. The source code can be loaded directly from this page shown here, and the sample code is clearly commented, making it easy to use and read. First of all, this sample illustrates all the steps you need to perform to create a simple application with a graphical user interface. To add a graphical user interface, we'll need to add the necessary visual components to the form of your application. This sample uses the image viewer, zoom viewer, document viewer, and the text editor components of the main form. One example of where this user interface application can be used could be a verification station where an operator reviews recognition results. Or this sample could be used as the perfect tool to test images and try to find the best pre-processing analysis and recognition results for each particular case. Now, let's run the sample and show how it works. Let's say that you're developing an application to archive documents. In this case, you can test your images using the Hello sample with the document archiving accuracy profile. Now, let's run this application. At some point, you may need to process an image and receive unacceptable recognition results. For example, you've created a PDF file with a full text layer, but some of the searchable keywords are not being found. Let's open our rich text format file. There's something definitely wrong with that file, so in this case, let's save the recognition results to the rich text format file, and we'll see what text layer is under the image within the PDF file. Look at these results. It explains why we can't find this document in the archive when performing a full text keyword search. We tried to process this image, and although this image is not the best quality, we still have to process it. So let's try to investigate what caused those bad recognition results. For this purpose, we'll run the visual components sample and try to read our image. Let's open this image. Using the Recognize button, we'll call the process method without any specific pre-processing settings. Take a look at the image window. You can see that text blocks were detected, but the text was read in the wrong direction. It was read from left to right when the text is actually printed vertically, which explains why the document was not full text searchable. Also, we can see that our text is shaped irregularly. Our recognition results are connected to the bad image geometry and text orientation. So let's try to manage this problem. The Edit Image button gives us access to the pre-processing tools. We'll try to correct the image orientation with rotation and correct the image's geometry. So we corrected the image's orientation by rotating the image. Now we need to correct the geometry of this text distortion. We need to correct the image's geometry, skew, and trapezium distortion. This image looks much better. Let's analyze this image. You can see that we now have recognized blocks. So let's read this updated document. You can see that some characters are highlighted. This means that we need to verify them because the FineReader engine was not 100% sure that they were recognized correctly. We'll run through all the highlighted characters, and if necessary, we'll correct and confirm those corrections. Otherwise, we'll simply ignore the suggested corrections. As you can see, after the document correction adjustments, we only had a few minor corrections. Normally, we don't need to make so many manual manipulations with each particular image. This is because the FineReader engine can do it automatically, and the results will be much better than with manual correction. We just need to use the right processing parameters. Let's return to our Hello sample. In our sample, we use the document archiving accuracy profile. So let's read more about that profile in the developer help guide. As you can see, this profile is not intended for converting a document into rich text format, docx, or PDF text only. For this purpose, we need to use document conversion profiles. Of course, we're not going to keep our rich text format file. We use it only for testing purposes and to check the text layer under the image. That's why we sometimes find additional characters recognized on pictures, logos, and so forth. This profile enables the detection of the maximum text on an image, including text embedded into images. There is no image geometry correction in this profile, which is why we had to do it manually. To do it automatically, we may need to set up some additional document processing parameters. In this case, we'll need text orientation and geometry correction, so let's return to our application. So we created document processing parameters, then we set correct orientation, correct skew, and geometry correction. Let's run this new sample with these new settings and see what we get. Let's test our recognition results. Much better. The FineReader engine did a great job. You can see we have some pictures left from our original image. To clean it up, we can crop the image, or for the purposes of creating the PDF file, we won't need it. So, in summary, the Visual Components sample is a great template to develop your own application using a graphical user interface. It's also a useful tool to test images and check how to improve your recognition results. We hope you enjoy working with the ABBYY FineReader engine. And for more information, please contact us today.